In this video, we are going to look at how you represent a linear pattern with a graph. And so we're going to remind ourselves of the rule y equals mx plus b, where x represents our figure number, y represents our number of tiles, b is going to be the number of tiles in figure 0, and m is going to represent the growth, or how many new tiles we're getting each time. When we look at growth can sometimes be represented as a fraction, and so m, the growth, is really how much does our graph rise compared to how much does our graph run. And figure 0 can really be our y-intercept as well, because that's where it crosses the y-axis. So we're also going to remind ourselves that b is our y-intercept. So keeping this all in mind, we are going to look at a rule, and the rule we're going to look at is y equals 2x plus 3. This tells us a few things about our pattern and our graph. The first thing it tells us is that our figure 0 is going to have 3 tiles, or that our y-intercept is going to be at 0, 3. The second thing it tells us is that it is growing by 2 tiles each time, and to write the number 2 as a fraction, that's 2 over 1, so that tells us that it rises by 2 for every time it runs by 1. So we're going to go ahead and plot some points to see what this graph looks like. So starting with a coordinate at 0, 3, what that tells us is that our figure 0 has 3 tiles on it. Then, to get the next point on our graph, we know that we have to rise by 2 and run by 1. So up 2, right 1, and we'll put our next coordinate. And then to get our next one, we will once again rise by 2 and run by 1. So up 2, right 1, to make our next one. And we can keep doing that pattern, that linear pattern, until we finish the rest of the graph. When we run out of room going to the right, we can reverse both of those processes and understand that if we run to the left, we can fall 2 as well. Once we have enough coordinates, enough data points to see our straight line, we can then go ahead and connect this all with a straight line. And so the straight line that we would use would look something like this. Put some arrows at the ends because we know that a line goes on forever. All right, once you've finished graphing your line, you really want to go back and make sure that you've done it accurately. So the first thing I always look at is that I should have a positive y-intercept because it's a plus 3. And sure enough, it crosses at a positive 3. The next thing I want to look at is that this has a positive growth. Notice that 2 is a positive number, which means that my graph should be increasing from left to right, and you will notice that this line is in fact increasing from left to right. All right, for this second example we're going to look at, the rule is y equals negative 4x plus 1. So remember, this plus 1 tells us that there will be 1 tile in figure 0, or that the y-intercept will be at 0, 1. This negative 4 tells us that this is a pattern that's actually decreasing, so it's growing by a negative number. So written as a fraction, negative 4 is negative 4 over 1, so what that tells me is this actually decreases or goes down by 4 every time it runs by 1. So we're going to go ahead and graph this. So we will start by graphing our y-intercept of 0, 1. So we go 0, 1 on the y-axis. Go ahead and put our first coordinate. And then remember, our slope, or our growth, is negative 4 over 1. So we're going to go down 4, right 1 to get to our next point. So from that point, go down 4, 1, 2, 3, 4, and right 1. And then from that point, down 4, 1, 2, 3, 4, and right 1. And then similarly, when you run out of room going to the right, you can also go to the left. So back to my y-intercept, I will go up 4 because I've got to do the opposite. 1, 2, 3, 4, and left 1. and up 1, 2, 3, 4, and left 1. You should now have a straight line of data points, of coordinate points, that you can now connect, because remember, linear means to make a straight line. So grabbing my line tool here, I'm going to start at that coordinate and bring it all the way down, remembering that a line goes on forever, so I put arrows in both directions. Check myself, I should have a positive y-intercept, and I should have a decreasing line because of this -4 growth. I have a positive y-intercept here at +1, and my line is going down from left to right, therefore it's decreasing. All right, for this last example, we're going to look at the rule y = 2/3 x - 5, and we're not going to let that fraction worry us at all because it's going to work exactly the same way. So this -5 right here tells me that figure 0 has a negative number of tiles, which seems kind of weird to think about, but all that really means is that I have a y-intercept at 0, -5. So that means that my line is just going to start below the origin. The 2/3 could say that I'm growing by 2/3 of a tile each time, or if I think about that as rise over run, that means I'm going to go up 2 and then right 3 each time. So let's go ahead and graph that. So starting with a y-intercept of 0, -5, I'll go ahead and put a dot right there. And then from that point, remember my rise is 2 and my run is 3, so I'm going to go up 2, right 3. So from that point, up 2, right 3 to make my new coordinate, and once again up 2, right 3 for my new coordinate, and just keep going until you basically run out of room. And then what you're going to do is you're going to reverse that process. So instead of going up 2, right 3, you're going to go down 2, left 3, until you get enough data points to make you feel like you can draw a line between all of them. And so I'm going to go ahead and get my line tool here, and we know that we want our line to go through all of those pink points, putting arrows at the end because it goes on forever in both directions. Once again, we want to check ourselves. We know that we should have a negative y-intercept, and this 2/3 is positive, therefore our line should be increasing from left to right. We have a negative y-intercept, it is below the origin, and it is increasing as we go from left to right.